Section 3.3, Slope-intercept form, Part 1. In this section, you are going to learn about the formula, slope-intercept form. Slope-intercept form tells you two things, slope and intercept, specifically the y-intercept. So the first thing I want you to do, and you can write this where it says solve it, at the top of the page 186, is the formula y equals mx plus b. You must memorize that, and you must use it all the time. Y equals mx plus b. There's only two things here that we need to know, the m and the b. So here's what it tells you. The m. The m stands for your slope. Now if you remember, slope is a ratio of the change in y divided by the change in x. Rise over run. So when you solve your equation, notice that your equation is solved for y. Your equation must be solved for y and then equal to your x term and then a constant. The m, which is your coefficient of x, is your slope. The b, which is after the x, is your constant. What that tells you is your y-intercept. And what is the y-intercept? That is where the graph crosses, where the line crosses the x-axis. So now on page 186, I want you to follow along in the shaded region. We're going to start with the second paragraph. A family of functions is a group of functions with common characteristics. A parent function is the simplest function with these characteristics. The linear parent function is y equals x. That's it, y equals x. Or we could also say f of x equals x. The graphs of three linear functions are shown at the right. So look at the graphs. The red line is your parent function of y equals x. The blue line is y equals 2x. And the purple line is y equals negative 1/2 x plus 1. You will notice that all three graphs are solved for y. And they all would be in the form y equals mx plus b. But y equals x and y equals 2x are the only ones that represent direct variation. So let's go on to the next paragraph. A linear equation is an equation that models a linear function. It's basically a line. When you graph a linear function, it's a line. In a linear equation, the variables cannot be raised to a power other than 1. That's a very important concept. So, y equals 2x is a linear equation. But y equals x squared and y equals 2 to the x power are not. The graph of linear equations contain all of the ordered pairs that are solutions of the equation. Every time you graph a line, that line represents all points on that line, which represent ordered pairs that make the equation true. Graphs of linear functions may cross the y-axis at any point. A y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. Here's your essential understanding. We just learned a whole bunch of vocab words in that gray region. You can use the slope and the y-intercept of a line to write and graph any equation of the line that you want. And here's your key concept, which I just went over. The slope-intercept form of a linear equation of a non-vertical line is y equals mx plus b. We're going to be doing the problems on page 187 now. Problem 1. Here's the first thing in this section that we are going to go over. Identifying slope and y-intercept. Now you will notice as we're going through here, everything in red in your book is the type of things you should do. It's like sections of things you need to learn in this chapter or in this section of the book. So problem 1 within section 3.3 is just telling me what the slope and y-intercept are. So if you look at the got it problem, what are the slope and y-intercept of the graph y equals negative 1/2 x plus 2/3? The first thing is you will notice it's already solved for y. So all I do is identify the m, which is your slope, which is negative 1/2, which is the coefficient of x, and b, which is after the x, is 2/3. Now what this means is your graph would start or go through 2/3 on the y-axis, and your slope would be down 1 to the right 2. Down 1 to the right 2. Rise over run. That's it. There's your answer for part A. Part B. How did the graph of the line in equation in part A change if the y-intercept is moved down 3 units? Well, there's two things you would do. First, you'd have to look at what happens to the slope. Since we're not changing the slope at all, the slope stays the same. But the y-intercept, where it crosses the y-axis, is going to go down 3. So we have to subtract 3 from 2/3. So 2/3 going down 3, that's going to give us negative 2 1/3. So that means our new y-intercept would be negative 2 1/3. Practice A. What's your slope? Y-intercept. Do this yourself. What would m be? M would be negative 1. What would B be? B would be 4. Number 2, M would be 1/4. B would be negative 1/3. That's it. Now look at the got it. What is an equation of the line with slope of 3/2 and y-intercept of negative 1? I want you to write your own equation. Now if you did it correctly, your equation would be y equals 3/2 x minus 1. That's it. We just plug in m and b and make our equation. I now want you to go to page 190. We're going to skip ahead to problem 5. Problem 5 is talking about graphing a linear equation. So if you look, the got it problem. A, we're going to do these two problems. So here is letter A. Y equals negative 3x plus 4. The first thing we want to do with everything is identify your m and b. But make sure your equation is solved for y. Here it is. It is solved for y. So your m would be negative 3, and your b is 4. Here's how you graph. Step 1. Always start with your b, where it crosses the y-axis. Now in this problem, it crosses the y-axis at 4, so we're going to put a dot at 4. Now our slope. Our slope is negative 3, but we always want to make that a fraction. So it's going to be negative 3 over 1. Now if you remember, the top number tells me to go up or down. The bottom number tells me to go left or right. Since the top number is negative, we are going to go down. Since the bottom number is positive, we're going to go right. So we're going to start at our blue point. We're going to go down 3. 1, 2, 3. And then we're going to go right 1. Right 1, there's our dot. Let's do that one more time. 1, 2, 3, right 1. And now we have a linear line, or a linear equation, graphed as a line that crosses those 3 points. Now obviously, you're going to use a ruler, your line's going to go through the points. But always then double check. Does my line go uphill, downhill, vertical or horizontal? My line goes downhill, so my slope should be negative. And right here it is. It's a negative 3. So we did that correctly. All right, the next problem. The next problem says y equals 4x minus 8. My m is 4, so that's going to be 4 over 1. My b would be negative 8. Now notice that my graph looks a little different because I don't need to graph the first or second quadrant or much of the third because we're starting at negative 8. So in this problem, my b is negative 8. So I'm going to start at the y-axis at negative 8 because that's where it crosses. Now my slope is positive 4 over positive 1. That means I'm going to go up 4. 1, 2, 3, 4 over 1. Put a dot. Up 4. 1, 2, 3, 4 over 1 to the right. So my line goes uphill. And make sure you put arrows at the end. It's not connecting the dots. You're just drawing a line through the dots. And there's my line. Now the next two are not in your book. So you can just watch me, or you can put it to the side, or you can just put it in the practice section where it says number 9 and 10 and use those grids. So let's do 2 more problems and then we will be done. We're going to start with example C. 3y plus 6x equals negative 12. You will notice that this is not in slope-intercept form. This equation does not solve for y. So now we have to go back to our literal equations and realize that I have to get this solved for y. So the first step, I'm going to subtract 6x. And you do not have to show this step. I would expect you to be able to do this without showing this step. So we'd have 3y equals negative 6x minus 12. I then have to divide everything by 3. So that would give me y equals negative 2x minus 4. My slope would be negative 2 over 1. My y-intercept is negative 4. So you can tell me right now what this graph is going to look like. My graph is going to be going downhill and cross through negative 4 on the y-axis. So if I graph this, my x and y, so I'm going to start at negative 4 on the y-axis, and because it says negative 2, I'm going to go down 2 over 1. Now you could go down 2 again, but I'm kind of out of graph, but you can go the opposite way. Up 2 to the left 1. Now you're going to say, Mr. Humphreys, wait a minute. Why are you going the opposite way? Going up is positive. If you go up 2 here, up 2, that is positive 2. But then I go left 1, and left 1 is negative 1, and negative 2 over 1 and 2 over negative 1 are the exact same thing. So if you do run out of room on your graph, just go the opposite way. And there's my line. The next problem, 2x minus y equals 7. Let's solve it for y. You know, let's make this, I'm going to change this. Let's make this 2/3. Alright, so I want to move the 2/3 x, so I'm going to subtract 2/3 x on both sides. That gives me negative y equals negative 2/3 x plus 7. I now have to get rid of my times negative 1, so I'm going to divide everything by negative 1. That gives me y equals positive 2/3 x minus 7. My slope would be positive 2/3, which means my line would be going uphill. My b is negative 7. So if I graph this, now once again, you do a much better job on your graph paper. Negative 7 is where it crosses the y-axis. Positive 2/3 will be up 2, 1, 2 over 3. And if you did it again, up 2 over 3, your line would be going uphill at a slope of 2/3 and cross at negative 7 on the y-axis.